Okay, let's choose a machine to modify. There are plenty of machines, desktop machines in AliExpress, in Amazon. For US customers, Amazon probably is preferable. For EU customers, I found out that shipping costs are much smaller when you order in AliExpress. There are several machines. Some of them are 1,000, some of them are half of 1,000, some of them are 600s. Plenty of machines. Generally speaking, patents are similar. A very cheap machine, even for 200s. How to choose? That's a good point. Basically, since I have narrowed all my needs to PCB milling, this machine will do only PCB milling. I'm choosing right size aluminum frame. All those machines has a bad linear guide components. You should deal with that, and you should accept and include it in modification costs as well. So I choose this machine. There is even some branded shop is selling it at the motor. Here's a 405, and I got exactly for 400, including shipping, some time ago. This machine became cheaper and cheaper, but it is a good machine to modify. And let's inspect this machine closer. Here is this machine, nothing fancy, but it has a linear guides. It is full aluminium, and it comes also relatively well equipped. It comes with height probe, it comes with a collet, it comes with some mills, some basic things. It also includes electronics for GRBL software. And in my case, I was lucky one. Those electronics were very good. I can run 5 hours long process without interruption. I can leave it unattended, and after 5 hours it is still working and there's no errors. What comes with machine is power supply, motor. What seller is selling as a spindle, but it's not spindle. It's a lawn mower motor. It comes with a laser. I didn't buy a laser. Have no any opinions about a laser. The machine itself, emergency stop, and you need emergency stop. Even with all my experience, sometimes I did something and don't understood what some error is happening. I just push emergency stop and then start to think what happens. Emergency stop is must if you want to professional application. Power switch, laser, reset. I never use a reset. My electronics working stable. Limit switches. This machine equipped with a good limit switches, and we already said probe. Offline controller. It's total crap. You don't need it, but you can buy it just to play at that early beginning when you put it together. Since I have more experience, I didn't buy it. Let's inspect machine a little bit closer. How does it look? And I will tell immediately about different lowlights as it is. They have T8 lead screws, and those are meant for 3D printing. And what is the difference between 3D printing and milling? 3D printing, you don't have a contact with material, you almost don't have a contact with material, and you have precise movement. But when you are milling or engraving, you have contact with material, and you need a strong frame resistance and system resistance to the pushbacks what comes from material and the mill, and they should resist it. At least that lead screw is not capable to do that. Another lowlight is how base is built. You can see here is 12mm shafts, hardened, good quality shafts, but those are built in a way that those are secured here and secured here, thin material, and those are guitar strings. Practically they can't absorb any milling vibration, and barely they are able to absorb light engraving in a PCB. But for PCB, those are okay. If you want to mill, you need to do more modifications. You should put second, this 40x40 extruded aluminum frame here, 4 holes. You should put the linear shafts, and the same here. It becomes a little bit bulky, but then it will be strong enough to do the milling. Actually, those 6mm aluminium thick sidewalls are relatively strong, but maybe you need to reinforce them as well if you want real milling. Also, when we are talking about supplied material quality, there are linear guides, and linear guides are low quality, but those are not smooth, but they doesn't play, and they are fully useful for my needs. But definitely they are far from the good quality rails. Also, I'm a little bit surprised about the manufacturer that they even saved on a screws, and only each second screw has been screwed. It's funny. You shouldn't save on a peanuts. It's just making bad impression about the company. How about a concept? And I like a concept that all electronics and power supply are secured on a frame behind the spindle. And I said electronics are great for that particular case. Power supply is a cheap with a noisy fan, and I personally replace it, but you can use it. It's 48 10 amps power supply. Supplied motors are good, and I have no complaints at all. As I mentioned, Spindle is a lawn mower motor, and when you buy, you shouldn't count that you're buying Spindle. No, you are not. My biggest disappointment was the Z-axis because those are developed as broken. There is a fundamental principal error. I explain it a little bit later, and this was unexpected case, but anyway. Also, I had the complaints about the screws, and really the sellers or those who are building generally well-designed device and saving on peanuts. There are 10 millimeters long screws, so screws are too short for that aluminium frame. You need at least 15-20 millimeter screws, and there is even thread for a 20 millimeter screws. I replaced all those screws because I disassembled all the system. This is kind of emotional thing. Why not to make simple things right, and you are dealing with a customer satisfaction. So here's a closer look on each components. All components are, those supplementary components are good quality. Especially good are limit switches. I was able to get 10 micron repeatable tolerance. This is absolutely excellent, fantastic, and many other great words. Good component. I try to buy those limit switches separately. No, those are not in open market. Somewhere manufacturer find a good component. About the base plate is great. I'm using it, and I'm using it after modification, the same base plate. But of course, there's extra holes for the modifications. One more thing about the linear bearings or linear bushings. In our project, we are using LM10 for the Z-axis, LM12 for the base, and you can see that allowed tolerance is +0, -6 microns, or even -9 microns. What does it mean? That means your linear bushings can be tight, but they shouldn't play. If they play, those are scrap components. Unfortunately, all those components are scrap. Probably they got it for free to keep a price. And you should consider budget to replace all linear bushings to a high quality manufacturer. I'm not in industry, I don't know manufacturers, so I choose a policy that I will take a brand, and THK is a great Japanese brand, and I know that those top companies, they are not producing cheap stuff at all, so if you buy, those will be good. Of course, it's also be 5 times or 10 times more expensive, but it's worth any penny. And I like this picture because it really shows why those desktop devices has been released in the market, and my Chinese engineers did absolutely great job for the kids, for those who want to learn. Those are perfect kits to learn, and this is how I position. And 400 euros are not paid too much for that, and if you do slight modification, you can convert it to a really working machine. Yeah, below 1,000 euros, you can build absolutely excellent and great machine. With all my errors and buying a lot of stuff and mistakes, because I'm not a specialist in that area, so I bought some stuff that I throw away. My final cost didn't exceed 800 euros for the quality what I shown. Genius business model introducing that machine, and it allows to do a lot of things for us hobbyists. Product specs, there's nothing to mention. And now, as I said, you don't get Spindle with your kit. It's lawn mower motor. and you can see it here. Here is a nest for bearings, and this is a rubber nest in the bearings. This supplied spindle can't resist any mechanical force, but those are silent and those work quite quiet. Also, there is a central axis or central rotation part, and if you are lucky one, then rotor is balanced. I was not lucky one, complete crap. But the problem is that it consists of two parts. Here is a collet part and here is a motor part, and when you have two parts, your potential runout always be about 100 microns. It's not acceptable for my project. I need 10 microns, 10 times. I tried to replace with another one. No way. It's developed or broken. Here's a closer look. Someone in a YouTube disassembled, and you can see the rubber shoes where bearings are placed. You can see, no way, no way. And why it's no way? This is standard mill, and the best mills are those single flute which are taking or grabbing large material and throwing away. Then you don't need to pressure there to blow it away. With those carbide mills, you can achieve best possible result. But how they work? They rotate, then they bunch in the material, and all frame and spindle should resist to that bunch and be rock solid and rigid. Coming back to that lawn mower motor, what is named as a spindle, you can see sheety bearings, and you need a better spindle if you want to really do something professional. And I found such kind of spindle. Those were introduced a couple of years ago, and now they are available in volumes, and I'm really thankful to the engineers who built it, because this is a good spindle on this low segment. And you can see for $100 or 500 euros you can get a full bunch, and you need clamp, you need spindle, you need driver. It is brushless spindle. You don't need RPMs indicator, because anyway for a PCB milling we are always running at a max, and I can even triple that frequency. This is limited by the spindle. Key features of spindle: 300 watt. You don't need more for that frame, because frame is not able to handle more powerful spindle. Even 300 watts are overkill. But anyway, collet ER11, that's great. Spindle accuracy, 10 microns to 30 microns. I was lucky one, it was a 10 or even 5 microns. I got a very good example. And you can see it is built in a way that this central part or rotation part or a rotor and collet nut system is made from the one process. It's the right process, and it's done in a high quality lathe machine, so you have perfect accuracy. A rated current 12 amps, so the maximum power supply what you need is 350 watt power supply, but for engraving it's running below 1 amp, and then it's a 36 watts. So for all your system you can use 350 watt power supply. Another challenge, dimensions of the spindle differs from supplied lawnmower motor, because it's 52 millimeter motor, and here you have 55 millimeters, so no way to put it in. There are several versions. I choose with DC 36 volts because it's perfect for my needs, and also it's optimum power supply for motors and for a temperature for my electronics. What are supplied? 48 volts are a little bit overkill, and this is ideal. And I replaced my power supply because I had in stock to 36 volts, fanless, and it's great. Long service life, low noise, everything. I agree with everything what is written here in a promotion. Great. Also provided driver is perfect. It's small in a size. It is well made, and it is working stable. I'm working for a longer time, and there is I forget that I have it. Yeah. Also, it comes with RPM adjustment potentiometer. I am using the same what I had, and there is on-off switch. I replaced the on-off switch with a relay, and relay is driven by GRBL controller, spindle power, and it drives my relay. Relay is connecting those contacts, and I don't have additional electronics for that. Supplied clamp. I'm lucky one because I got a very good clamp. Here the surface doesn't seem so smooth, but when I bought it, it was supplied with a very high quality clamp, and it fits excellent, and it's rigid. We will look at a real design later on. Another super important thing for your tolerance, because we are crunching microns, are collet and collet clamp. It seems simple task, and I tried to buy several China manufactured clamps, what was stated as super precise. A huge disappointment. There's nothing precise. I bought 10, and from the 10 I was able more or less find one, and then I bought another bunch of 10 from different manufacturers. Finally, from 20 nuts, I was able to select one which was good. So what you can learn from my mistakes, if you have a local American, German, or Japan produced ER11 collets and nuts, take from the proven brand. Even it costs $50, it's worth, because I spent more until I found the right one. $50 is a fair price if you have, or you need, a high precision. And then I have almost negligible runouts. Also, I recommend to buy balanced collet nut, because those are rated up to 30,000 RPMs, and who knows what will be in the future. But in my particular case, I have a 12,000 RPM spindle, and this is conscious decision, because any other solution, if you go with a higher RPMs, there are spindles available from 30 to 60,000 RPMs, but then you need a water cooling system, and then all your system become bulky. A little bit about my largest disappointment, that axis, because generally it was built okay, and I liked the design and construction, and even the clamp is okay, I can modify, but anyway, but there is a huge error. It's developed as broken, and this is this block, and you can hear it's loose. Yeah, it's loose, and it is huge problem. You can't stay with that. Listen. Metal casted technology, and I understood it's about a 10 micron precise technology, but what they did those holes where our linear bearings are too large, and bearings are not sitting tight. There's a wrong methodology, and when they are not sitting tight, there's always abrasions that gives you final error, and all your project is crap. So what would be right methodology? Right methodology would be make this or cast this hole for a bearing smaller, and then use precise process with some 10 micron tolerance, making that hole 10 microns smaller or 5 microns smaller, and then push with a effort or with a pressure, push those bearings in it, and then it would be perfect solution. Huge disappointment, impossible to use. At least in my case, I should add an additional $100 for a good Z-axis spindle holder. What are options? Here I found one which I took as a base. This is a optimized standardized solution with a ball screw. In my opinion, it's good. Those are $100 or €100, and it's honest price. It also can accommodate NEMA 17 and NEMA 23 motors. In our case, we can use only NEMA 17 because electronics doesn't support current ratings what are needed for NEMA 23, but overall this is a good solution. In my particular case, there is a second lowlight of that Z-axis design. You can see there is extruded aluminum profile, and this aluminum profile has a 20 millimeters height. and also significant mass. And when you put all together with a spindle, it's about 3 kilograms. It's too much for such a small PCB milling project. So I made it by myself, but it was based on that pattern. And now let's take a brief look about all modifications made on a real machine. I will do some basic explanations about that, and also mention some or pay attention to the critical things to do.